I'm a game changer. I'm a risk taker.
Good afternoon, the honorable participants on this Zoom meeting or even on the YouTube live streaming. We are IRIS, and IRIS stands for ITS Robot with Intelligent System. But before further ado, let me introduce myself. My name is Danendra Clevero Ananda, and I will be happy if you call me Danen. And I'm here as a representative of IRIS. And I will present to you and glad to discuss with all of you about our presentation. IRIS itself is a robotic team in Institut Teknologi Sepuluh Nopember in Surabaya City, Indonesia. Right now, IRIS has 22 active members inside the team with 4 divisions: programming, electronic, mechanical, and official. And in this beautiful day, we would like to present to you and glad to discuss about our research about methods on increasing goal probability. First, we'll talk about middle-size league. What is the purpose of it? Middle-size league itself is a 5x5 robot competition which aims to score goals as much as possible. The winner will be determined by most goals, but there is a thing that we want to solve. The thing is, right now, at least 30% of robot shot can't score any goal. It's deeply regretted because the chance to shoot is a very rare chance. It would be a big advantage if robot could maximize this opportunity. And you have seen robots failure on making score by this video. Then, a question will come up to our head about how to increase the scoring probability from robot kicker. Now, let's see some upcoming video clip. First, we have the long-range kick by some football player. All of that kids are aiming to the same direction. It is the top corner, no matter the top left or the top right of the goalpost. From all of that shot, we could take a conclusion that there are 2 main keys on scoring goal to goalpost. First is a powerful kick, and second is the ball direction. And according to analysis of torques and forces applied on free kick in football 2010, the minimum ball speed that required to overwhelm the goalkeeper is around about 50 km per hour. There are a lot of factors that take effect towards the generated ball speed, like foot weight and foot center of mass from distal point, etc. But the most influential factor is how much power given to our ball. Kicks that are difficult to predict are kicks that have an intersection angle. To make the ball have an angle of intersection, a soccer player must kick the ball at the center mass point of the ball. Then, the ball is kicked sideways using the inside of the foot, causing the ball to spin. When the ball is moving, the air will be in the opposite direction of the right. When by shooting the center of mass of the ball, it would be better. Why? Because there will be no energy that being converted to spin. The kick that would make the goalkeeper overwhelmed is a kick that aiming to the farthest point from the keeper and aiming to the farthest pole at the same time. In this case, it's the top left or right corner of our goalpost. Actually, this technique has been discovered before, but sadly, it's still hard to implement this technique in real life due to some reason, like player skill. And now, the question is our robot ready and capable on doing this kind of test? To make it happen, we still need some more improvement, either from the hardware and even the software. First, we need to improve our kicker. Previously, our robot uses brushless motor with gearbox to increase its torque. You can see our old kicker in your top right screen, but this method has some disadvantages that it is not fixed, so sometimes it could detach from our robot. Sometimes it also hit a robot's cable, and the kicker sensor are not that sensitive, so sometimes it doesn't detect any kicker motion. Therefore, we changed our system to solenoid, and we are aiming for 17 Newton meter of torque value. Therefore, we use the following equation that you can see in your screen. From these references, we also get very good solenoid specification to be applied as kicker, and we have implemented them to our robot with the following specification which you can read in your own screen. And to decide the kicker's direction, we will need goalpost and goalkeeper's position. Therefore, we add camera sensor to take the visual data. We use webcam because it has a wide angle and automatic low light correction feature, which help goalpost detection. From our webcam data, we would proceed through two steps of verification. First, we will use YOLO classification, and in this case, we are using Tiny YOLO version 5. Why? Because it's lighter and have a higher accuracy. Then, we will add filter to verify the data to prevent a false detection. Here is some technology set up to generate the desired output, and from the left side, there are kicker, camera, and kicker test using solenoid. First, we have our processing technology. From this classification, it will decide the direction of the ball to the upper right or left corner. This position will surely overwhelm the keeper. Next, we have field system testing. We use some different variation of robot goalpost distance to test our algorithm flexibility, which we have developed before. We also add humans role to pass the ball to test the robot's speed and latency when it sees goalpost for the first time. Our algorithm with YOLO could classify some objects like goalposts, robots, right top corner, and left top corner with accuracy up to 95%. And to prevent false detection, we also use additional filter to verify that it is a goalpost and not a normal ball. And we also use a fuzzy controller to set the ball's direction to top left or right corner. This algorithm is important so that even the robot has a different position, the top corner kick will be stable. Besides, we also use capacitor discharge voltage variable because the kicker speed depends on it. And you will see a table here, and here is some chart record of some different distance and height variation, and also some encoder variation. The graph that you see here is the distance and capacitor voltage comparison. The top corner left and right look almost the same. From all the 40 tests are able to make a score, which leads us to a conclusion that it has accuracy up to 100%. So, how about coaching a real goalkeeper? Before that, we have to set some systems that we would use. We have to make a class that has a person, goal, top right, and top corner variable. Then, we set the target to 2x3 footballs goalpost size. We also need to tune our capacitor discharge voltage and position encoder to match the 2x3 goal size. Our subject is an amateur goalkeeper from Temanggung Futsal Club. Our target is to determine the weakness of the keeper. Based on the statistic of some random kick that done by our robot, the direction would be the top corner to overwhelm our goalkeeper. And we have divided our goalpost to 9 parts to define the keeper's weakness. And the upcoming video is a video of our goalkeeper praying with our robot. From all of that tests that has been done, we can make a conclusion that our goalkeeper has weakness on goal number 1, which means it is the top left corner. Last but not least, we can take a conclusion that the success rate of goals can be increased by increasing the power of the kick and directs to the far post so that it is difficult for the goalkeeper. And by using robots and deep learning, futsal goalkeeper can be trained to determine goalkeeper weakness and improve reflexes. And for future development, we will make a design of a goalkeeper training using this system with a wider scale. And in this case, it's a football goalkeeper trainer. And we think that's all we got for today's presentation.
Iris is ITS robot with an intelligent system. This team focuses on soccer robot development. Our robot has many abilities such as passing, kicking, obstacle avoidance, positioning and dribble, and also keeper defense. Iris has joined a lot of competitions such as Contest Robot Indonesia and RoboCup. On Contest Robot Indonesia 2021, Iris got second place and best design.
Juara kedua, Iris, Institut Teknologi 10 Nopember. Desain terbaik, Iris, Institut Teknologi 10 November. Maka diputuskan juara umum Kontes Robot Indonesia tahun 2021 adalah Institut Teknologi 10 November. Terima kasih.
And then, on Contest Robot Indonesia 2020, Iris got first place and also best design. And then, ITS also got General Championship for 4 years in a row. For your information, Iris not only participate in competition but also contribute in the health sector to help nurses, especially during the pandemic, with Raisa, a robot medical assistant, and Violeta, robot ultraviolet. Raisa can help nurses on doing their tasks such as bringing many items, measuring the patient body temperature and oxygen levels. 22 units of Raisa has been used in 17 hospitals in Indonesia and still increasing its number until now. Besides Raisa, Iris also contribute at the development of Violeta, robot which has the ability to sterilize a room with UV light. In addition on conducting research and development on robots, we also have a program to introduce the world of robots to students with the aim of increasing their understanding of the world of robots. This year, it was held at MTS Nurul Islam.